All right, so let's simplify radicals with the nth roots. So determine the largest perfect nth power factor of the radicand, and then use the product rule to factor out and simplify this perfect nth power. All right, so we're supposed to simplify each expression. So we have square root of 500. Well, we're going to break it apart now. Instead of multiplying it together, we're breaking it apart. So if we have 5 times 100, we could take the square root of 100 and get 10. So we have 10 square root of 5, and that's how we're going to do it. Now we have to think about the cubed root of 40. Well, what's 40? Well, that's 8 times 5. 8 we can take a cubed root of. That's going to be 2. So that's going to give us 2 cubed root of 5. What about 72 square root of? Well, that's what? 9 times 8. And so square root of 9 is 3. And then we still have the square root of 8. Well, guess what? Square root of 8, we can break apart into square root of 4 times 2. And square root of 4 is 2. So we have 2 times 3, which is 6 square root of 2. Now, if we would have seen that it was 36 times 2 and we could do this, the 36, that would work too. But at first, I just saw the 9 and the 8. And so then I took the square root of that and the square root of that. So that was 3. Well, then I was like, oh, I can break that into 2 and 4, square root of that and square root of that. So that gave me 2. So I have 3 times 2 is 6 times the square root of 2. So you can go about these again in many different orders. Just depends on how each individual brain works, but you'll end up getting down to the same thing. You have to get it to the most simplified expression, and then you'll get to the right answer. All right, so simplify each expression, assume all variables are positive. All right, so 49, x to the fourth, the square root of that. Well, the square root of 49 is 7. The square root of x to the fourth is x squared, and we have it. And all they did was they kind of split it apart into those two things and then did that, but we kind of did it in our head. What about 75? Well, we can do a 25 and a 3, and then we can do a y to the fourth and a y and break it down into that. So we have a 25y to the fourth and then a 3y. So we had the y to the fourth and the y and the 25 and a 3. So this one we can take the square root of, which is going to be 5y squared, square root of 3y. And that's end up as our final answer. Now here's one that we really have to multiply together first because we're taking cube roots. Here we have a 1, here we have two of them, here we have 1, here we have 2, then we have a w. I don't know why the w in there, but anyway. So when we multiply that, what do we get? We get 27a cubed, and then we have a w. Well, 27a cubed, the cube root of that is going to be 3a, then cube root of 3w, cube root of w. So 3a cubed root of w. Okay, so again, just playing with things gets it down to something that makes it simple that we can simplify. All right, what about this one? Now we have a square root of 7 times a cube root of 7. Well, now we don't even have the same n power, so we can't do what we've been doing. So what we have to do is we have to convert them to exponents. And when we do that, now we can multiply, or well, we multiply the two, and when we do that, we have to add the exponents. And so we have 7 to the 1/2 plus 1/3. And so when we get the common denominator of 6, we'll have 3 plus 2, which is 5. So we have 5/6. What about here? Well, here we have a cubed root and a fifth root. So again, we have a to the 1/3 times a to the 1/5. Now we add those together and get a common denominator, and we get a to the 8, a to the 8/15. Can't talk here. Anyway, so that would be what our final answer would be on that one. All right, let's stop there and come back for some more.